Hi guys, let's talk about how we're going to add the resistance in a series circuit and a parallel circuit. So what a circuit, which you've already seen in the readings, is looks kind of like this. You have your battery here, and this is the negative, and here we go. We're gonna put one resistor here, which is 12 ohm. We're going to come in and put another one. This is 9 ohm. And we're going to go up and maybe let's add one here. All right, and that's 5 ohms. The thing to know here for a series circuit is, how do I know this is a series? Is because it's all one. It's like all one big loop, okay? It's like one big loop. And that's how you know it's a series circuit. So in order to add the resistance for R total, you will just add them the way you see the numbers. 5 plus 12 plus 9. And that's exactly how you add the series resistance, okay? And that's going to be, what is that? 26. And that's your answer, okay? Let me know if you guys have any questions on that. Pretty simple on that. Adding, the only thing to remember is that what distinguishes a series from a parallel is that in a series, the circuits is just one big loop, okay? So which means what? If we were in the class, I would have you do, and you guys watch the videos on that too, where Bozeman was showing you with the FET simulation, that in a series, as you tag on more bulbs, the lights start dimming on them. And that's what happens in a series, is that the light starts dimming as you keep adding more bulb. And if the one bulb goes out, the whole none of the other bulbs are gonna work, okay? And that's how the old Christmas lights used to be. If the one bulb did not work, the whole string of lights would stop working. Okay, and that's the series. Let's talk about the parallel here. The parallel circuits are going to look something like this. So once again, we're going to start off with our battery here. Okay, and so let's do this. And this. So as you can see, it's kind of splitting and flowing through different paths. It's not one big loop. So this is going to be my 4 ohms, 6, and 12. Okay. So it's sort of like going here. You've got this pathway. You have this pathway, right? You have this here. You have this here, and this. Okay. So as you can see, it has multiple pathways. All right. So the beauty of the parallel circuit is that if the light bulb goes out in one of these, the other light bulbs are going to work. Okay. So let's go ahead and show you how to do these, add these. So R total is going to be, you're going to do 1 over 4 plus 1 over 6 plus 1 over 12. And then my suggestion is go ahead and put these in your calculator, and then 1 over 4 is going to be 0.25 plus 1 divided by 6 is going to be 0.17 plus 1 divided by 12 is going to be 0.083, and then you're going to add these together and you will get 0.50, and that's the resistance, okay, the total resistance in a parallel circuit. All right, so I hope this helps. It's pretty simple calculations. The reason I ended up doing it like this here, because notice the denominators are different, okay? So I wanted to do them individually than all together. You cannot, that won't give you the right answer. Students have tried to do it before where they just put them all in and it doesn't give you the right answer, okay? So just once again, I want to reiterate that the defining characteristics of a series circuit is that there is only one path for the current to flow, and the current is flowing in a clockwise direction, as you can see, you know, or from one point to the other. Okay, like this, like this, like that. All right. And then in the parallel circuit, you know, if you notice here, we had 3 resistor, but there's more than one continuous pathway for the current to flow. So each pathway is sort of like a branch. And once again, the defining characteristics of a parallel circuit is that all components are connected between the same set of electrically common points. Okay. And then, you know, you can always have a circuits that have combinations of both series and parallel circuit. All right. So this is what you need to know for our standards. And I think it's pretty simple, and you guys can do it. Let me know if you guys have any questions. Thank you for all your hard work.